Hello, folks. Thanks for taking a look at today's blog. The topic today we're going to be covering is Eiger software. And so Eiger is a software that is developed by the guys at Markforged. It works with their 3D printers, which we'll be covering in the future series. But let's go ahead and talk about how to get files in Eiger and how to navigate Eiger for the first-time users. All right, so to get a trial of it, we'll have this posted link here with the YouTube video. You can go out there and actually try Eiger, so you'll be able to do everything I did. So let's get into it. So first off, we'll need to get a model to print. All right, so I'm just using Solid Edge. I'm going to export this out as an STL. A couple things to take a look at. So first off is the export values. This was an inch model, but typically my Eiger is typically set up to be imported with metric template. So when you save as your STLs, you have to set some options here. A lot of people just say file save as STL and don't think about the options that are getting exported. So let me throw this folder called STL. So look at the options here. So again, I've done this before. Typically, it may be coming in at course. So what will happen is your models will be really faceted. So I'll save one like this. So I get these a lot of times when I get files to print. So I'll say bearing block, course, save. All right, let me save it again. And we'll do this one as bearing block, fine. And say okay. And again, millimeters versus inches. So I always export as millimeters. That way I don't have to do any tweaking of the files when I bring them into Eiger. I just save them in the correct format to go out of Solid Edge with. Even though I drew it in inches, millimeters is fine to export the STL with. All right, so I'll set it as fine. All right, so that's the first part. So second part is switching over to Eiger. All right, so let me jump over there. All right, so the first time you're going to be using Eiger, if you haven't created an account, you'll have to go in and create an account. It's very simple. So you just create an account, give your name, number, phone number, etc. You can create a password, and this will link to your printer. So I'll show you what I'm talking about as soon as I sign in here. All right, so this is the web-based version. Or cloud-based version. There's also the version you can download. It's an executable, but that does have some drawbacks. It doesn't automatically update your printer with new firmware, which does come out pretty regularly. So you'd have to go out there and manually go look, which is not hard to do. So I'm in Eiger right now, so this is where you import files. But let's go take a look at some of the settings first. So over here in the right-hand corner, you'll typically find the settings right there. So first off, if you just want to, don't really need to look at the terms of service, that just kind of gives you some legal information about Eiger. So again, this is where you can download the firmware. So if I download it now, put it on a flash drive, bring it over to my printer, plug the flash drive in, and update the firmware remotely. All right. Again, that's not hard to do. It's just tedious. It's much better to just walk in front of the printer and hit the update now. Of course, your printer will be online and it's directly connected to your Eiger account, so you'll see your printers, which is real nice because I can print from anywhere. I can actually print to our main headquarters, St. Louis, our industrial series printer, and I have the Mark II here, a local office. So I don't need to download that. So let's go to the next setting, an account. All right, so this is where you set up your name. We have multiple people in our office. So go back to, where am I going? Oh, library here. And you'll see all our users. So these are all the users we currently have signed up to be able to import files in Eiger. It's nice to be able to sort by those. So you can actually sort by who created them, just alphabetical name or date they were modified. So it's easy to find your files in there. So everyone should have the same account, so you don't have to set up individual and send each other STLs. Everyone can just share through here. So if I wanted to use a file somebody else created, which we have a few files in here, most of these are mine. but for example, here's one from our sales rep. I can go into that file, and if I wanted to, I could just clone this part, and immediately that becomes my part, which would allow me to modify the settings, add carbon fiber. If it's a different printer, I can send it to a different printer for different things. So now this part is mine to do as I wish. All right, so again, back to the settings real quick. So back to the accounts. So those are the people in our accounts. Some of the settings, again, preferences, metric, graphics, ultra. I don't really know what why you would go lower, but if you have a fairly decent workstation, I would just leave it as default. And if you want to enable dual signature sign-ins, you can do that. All right, so over here on the left, it's about the same stuff you just saw over here on the right. So pretty much the exact same information. This does have a couple other things. So for the dashboard, you get all the files you printed, when you printed them, what type of material usage, and that way you can track how much usage of plastics is going through the printer, so you can order on regular schedules, or just keep track of how much is being used. Similar to that, of course, your print history. These are just the past few. We just keep hitting more. You'll see the 500 something odd prints we've had of our printer. So these are just the list of onyx and carbon fiber. So if you hover over it, it'll tell you what that material was, and of course who the actual printer person was, the time, and the actual outcome of the actual model. We have I use the Mark II quite successfully a lot. Really good surface finish, really strong parts. So you get this little bitty thing right here. You can, once you're done printing, at the printer interface on it in the front, you just tell it how bad or how good it was. And this gets tracked by Markforged. So they're tracking worldwide prints and making sure to see any spikes or any downtime. So if there's any elevated downtime, maybe people had some bad prints, maybe something went wrong with the firmware. So this is a way to get that across to Markforged, how well the things are going. All right. So speaking of Markforged, in case you do have a problem with something, an issue, there is online support. So we can just go over to the support button right here, and we can log. So we do, again, we have the X5 at the office, and I have the Mark II. So if I had an issue with the Mark II, tell it which printer version you have, and you can go and take a look at information. Maybe you notice and you get some filaments sticking out of the part, or you're getting some bad surface finish. So you can just kind of go through and look for maybe some quick start guide if you're, again, first time user. Again, some more information on loading plastic, unloading plastic. It's very simple. The interface on the printer itself is pretty much completely error-proof. It reads very well, load plastic, unload plastic, etc. But just to take a look, set up and load plastic. So you'll get some hardware when you're setting up the printer. Some of this is stuff you would actually get with the printer. This is where the material is stored. Basically, you just say materials, load materials. Tell them if it's a metered load or quick load. Metered load is you actually weigh the material going in, so you can use partial spools. So you never really have to have material sitting on the shelf. You can always keep small bits and use those for smaller projects. Quick load will just load whatever you have. Be warned, you can run out. If your model requires more plastic than's on the spool, it will continue to print. I inadvertently done that. So letting you know that can happen. Tell it what type of material, nylon or onyx. We have the two base plastics. Nylon is the clearer one. Onyx is the dark black material. And whether it's partial, full, and give it the weight. If it is the meter load, tell it how much it weighs. And next. And basically start feeding the plastic in. As soon as it catches the feed wheel, it'll just go all the way to the end. Once it starts extruding out, hit stop. You know, the front interface is, again, idiot-proof to be able to load the plastic, unload the plastic, as well as all the other commands that we can do. Leveling the print bed, again, that's different for a print bed, so I won't really go into that. And of course, all your other articles for maintenance. So these are when you would want to replace the plastic nozzles, when to adjust the belt tension, and how to adjust the belt tension. So this is all online. If you do need to have a little more information than is available through this link, And if you call us and we're not available, you can always submit a ticket directly through Eiger. So you come over here, submit a ticket, tell them which printer you want, submit a request, tell it what type of issue, part quality, hardware, what have you, and it'll sort the question to who it needs to get to. So if it's a support question, just log in for like a support, tell it what the problem is, and submit it. So you'll go directly to the guys at Eiger. And if you go over to their webpage, also they're active on their actual Eiger webpage. Let me get back to. So if I head out here for a second, we'll get somebody that'll pop up and say, hey, do I have any questions on any of the printers? So they're actively receiving emails or actively on their website answering questions to customers. They're incredibly good about that. Oh, here we go. So if you have a question immediately, you can go to the website and log something. But again, if you have a printer, the best way to submit a ticket, log it through here. All right, so back to the Eiger software. All right, so I'll walk you through the, all the settings here, support, creating an account, that information. Oops, what am I going here? I want to see if there's any notifications. Nothing's printed, everything's finished. All right, so let's take a look at my print history again. If we want to replicate, we can also reprint items here. We can just click any of these and go right back into Eiger. So this is an STL that I previously brought in. If I wanted to bring this in with another file to print with, I can. So let's go ahead and do that. So let me bring those STLs I created a second ago. All right, so a couple ways to bring STLs in. You can either drag and drop, so you can come out through Windows and, for example, go to my desktop. Let me bring the first STL in just by dragging and dropping. So I can just drag and drop in again. And so this was the very first one I brought in as coarse. So you notice it's set to be, it was supposed to be round. So at the most coarse settings, it looks absolutely terrible. So that's why I always go ahead and get rid of this. Don't save it. And let me go through import the other way, just through the Eiger software. So let's bring in the fine one and take a look at the variation between the two. All right, so yeah, now the bore on this one looks a lot smoother. So just by adjusting that little output in your CAD file makes a huge difference. I'd say all mid-range and high-end CAD files have that. I can't verify if some free stuff that you get off the web, like maybe Google SketchUp, if that has the ability. But I know all your SolidWorks, Pro E, Solid Edge, and X type of tools will have that ability to refine your geometry. All right, so the first thing I'd notice is this part comes in red, telling me that it is too large for my actual build volume. So we can always scale things and or rotate it. So you have to look at bringing your files in and orient them, because there's going to be support material. All right, so if I printed it on this side, all right, if I print it on the side, I get no warning messages, but I know for a fact that I will have a lot of support material that will have to support this face right here as it's printing. So I'll have this edge of this face with support material contacting it, which is not a bad thing. It just doesn't leave the best surface finish as a face that doesn't have the support material. All right, so in this scenario, I would have no other option than to print in this orientation or move it over to the industrial series. So if I move it over to the industrial series, I have a larger build volume first off, pretty much twice the size. So I could build this laying flat. All right, so now when I'll have my surface finish, the bearing in the middle won't have any surface finish, nor will these faces, nor will the side faces. Really, the only thing that would get surface finish that would have some degradation would be right underneath here to support this. And again, I'm not 100% sure. It really depends on the face angle of this. We typically will not have to print support material if it's a 45-degree angle or less. All right, so if it's greater than that overhang, so like 40 degrees from this face up, then there would have to be support material regardless. So let's just take a look at what this is going to do. All right, so currently it tells me my dimensions of my geometry. So I'm going to go ahead and say calculate. So it's going to go through and slice based on just basically running pure onyx, no carbon fiber or no any other type of fiber. So just see what it looks like just running base plastic. Now this takes a second to slice. And once it does, we can go in and interrogate the interior of the geometry. And that will be done here shortly. I could have multiple versions of Eiger running, so if I needed to. All right, so sometimes it takes you to the terms and service. We just need to go to eiger.io, takes me in there. You notice, so we have things going in the background, so I could just basically bring another model and kind of show you some stuff on the internal volume while it's doing it. So let's look at this Flange Tool. So first is once it's done, it's going to give you the detail, like how long it's going to take. This is a pretty large volume of parts, pretty big size. All right, and how much it's actually going to cost in materials. So let's take a look at the internal volume. So this takes us into the slicing of the part itself. So once we do this, we'll be able to look at X-ray views of the part, see where the support materials are hitting, and if they're going to be any issues. All right, so here's my part. So first off, we can take a look at the visibility. So I mentioned the parts with the 45-degree larger than faces. So if we wanted to see, we'll take a look at once that part is in there, we can take a look at the actual support material. So say support material. So this is the support material itself. So you can kind of look at it by itself and see how much and where it's actually going to be printed. Then it will actually look at the wall. So that's the outside faces of the part itself. All right, so this is the actual physical geometry of parts. All right, and the floor is what's represented at the very bottom of the geometry. So typically if you're running carbon fiber and you tell the software to go ahead and do it, it will add carbon fiber at the very 3 layers or 4 layers into the floor, and the same thing at, well, what they were called the top of the part. So it automatically do that for you. So there's the floor area, top and bottom. So that's the top, floor, bottom, and that's what will put the supports above that, depending on what type of fill you use. So if I forgot to actually mention it. So let's go back to the other part. It should be done. Yep, it's done. So we're looking at this part on the industrial series, a 2-day print, $104 in material, 463 cubic grams of material. So this is a very large part. So it's, you know, just to let you know that this is a big chunk of material. All right, so let's go ahead and take a look at some of the settings. As I mentioned a while ago, if I was going to run carbon fiber, if I was going to do other things, of course, that will adjust the time and that will adjust the cost. And it will also tell it what type of interior hatching I want. So let me get my go-to-meeting out of the way here. All right, so first off, we're on the industrial series, so let's look at some of the part settings. Use supports. So we're going to take a look at if it does any supports or not. Raising the parts. All right. Oh, well, we actually need to go back to support too. I kind of skipped over the turbo supports. Turbo supports are a way for the printer to print large support areas. So if this part was up here, it's going, if you don't have the turbo supports on, it's going to print a really fine mesh of supports all the way up to this face. And if it goes up to here, all the way up to here. All right, so how turbo supports work is it prints a large profile section of support material. Then as it gets closer to the part where it actually needs you to touch, it will actually print a finer surface. So that way you'll get a better resolution on the surface, and there's no deformation in the profile or the surface geometry of the part. All right, so that is what turbo supports are. And of course, if you wanted to adjust the support angles of those, and again, it's relative planar. It's not the angle X, kind of XY, or excuse me, Z. It is a more planar XY orientation angle. All right, raising part. On a part like this is massive. It's got a lot of surface area at the bottom. I would never need to raise this, but certain situations where if you maybe had a part with some detail in the bottom and it's going to put support material in there, sometimes you want a little more support material so you can raise the part off the table. That way it gives you a little more support material to pull off the part a little more purchase on the material, so you don't have to dig it out of small features. Expanding thin features. If you do have some geometry that is unprintable for purposes, you can actually hit some of these little question marks out here. It'll actually tell you what this does. So select this. If your part has extremely thin walls, you need to preserve all the expense at the expense of some dimensional accuracy. All right, so all these have little question marks outside if you do need to actually take a look. And of course, Brim is actually printing extra support material around the outside of the geometry. So at the base, if you have a part that may be thin and prone to warping, we can print this extra support material around the base of it that will make sure that it doesn't delaminate or have any issue warping on the board. All right. And of course, I told it to come in metric and the scale. And here we actually have our layer height. All right, so on our industrial series, we can go down to 0.05. And if we go up to the Mark, or down to the Mark II series, it starts at 0.1. All right, so for printing in any type of filament using carbon fiber, glass fiber, carbon fiber, or Kevlar, we'll have to use the 0.125 to start with. And if it's something you quick and down and dirty you want to do, you can just bump it up to 0.2. It's going to leave a not as good surface finish, but it will cut, obviously half the time. If I went from 0.1 to 0.2, it's going to print twice as fast. All right, so last one to take a look at, the density and the type of fill. So a while ago when I looked at the cross section in the actual X-ray view, it asked me which one do I want to look at. So here we can define the different type of fill values we have for our geometry. It doesn't really print the part solid. It doesn't really need to for the extent of strength that it has. You can get away with using, typically triangular fill is the default. So, then you tell it how much adjustment of triangular fill. So this would actually obviously make really tiny little triangular fills, or would actually make the part solid. And of course, this would, I don't know what 0 would actually do. It probably, honestly, I have no clue what it would do. But typically in the default is around 50. So it actually gives you some warnings over here saying, hey, you're recommend 50% fill, but you're below that. So of course it would give you the same exclamation if you bumped it up to 100%, saying this will increase print time. All right. And the last couple things is roof and floor layer. So again, roof and the floor layers. So how many layers do you want on top? And how many layers do you want on the bottom? So by default, 4. So if you want a thicker piece of geometry, you can bump it. I think, maximum's 10. And I believe the number of walls, so these would be considered walls. All these outside profile faces would be walls. I think 5, 4, 4 is the maximum you can do on those. So again, this will tell you this, you can do that, but it's going to add a lot more time, but you will have a stronger part. All right, so you're going to have a lot thicker. So in the consideration, you may have to do some machining or some sanding for a particular reason. I would go with the maximum layers of roof and floor. That way you have some material to sand away with, and you won't get down into the actual fill of the geometry. So let's go ahead and bump these back down to a reasonable. Oops, get down. There we go. And 4. All right. So let's take a look at the internal view. All right, so this actually does, and you can actually see the turbo support. So these are actually larger supports down here. They get smaller as they get closer to the surface. Again, if we want to take a look at the visibility, turn off the actual support material. And of course, you have all your triangular infill, was what we actually use. So if you turn that on, a little harder to see what's going on. It's a little busy. But you can actually see where the actual part profile is going to be printed through all this part, this triangular fill. All right, so let's take a look at adding some fiber into this part. So back to my part view. So we can just switch back. All right, so now let's switch over to saying reinforcement material. And again, each one of these gives you a little information about if you want to learn about the Kevlar and its properties. Carbon fiber for stiffness, Kevlar for surface, for basically abrasion resistance, Glass fiber is the cheapest, and it is really strong. So the fiberglass itself will resist high temp, but there is a specific high strength, high temp fiberglass that will go higher than your base fiberglass. So let's go just carbon fiber, because that's actually what's currently in my printer. So if I try to print with something else other than what I have in my printer, it will tell me a warning because it knows I have carbon fiber in my printer currently. All right, so let's go ahead and just say save. And it's going to do a little slice on this again. And it's going to figure out, again, at the base floor and at the roof where this carbon fiber is going to go. All right, so once you're doing the carbon fiber pretty much any of these reinforcement continuous filaments, you have to kind of get a little tricky sometimes depending on the orientation that you want the strength laid in. Again, because we're laying it planar to the base and it moves in the Z direction. So all the layers itself would have in this direction. So if your part needs to be pulled a certain direction, you may have to orient a part that's not in the best orientation for printing for surface finish, but for strength, you would want to give that up just to be able to have that strength ability. You can always sand the surface finish, but you can't make the part stronger without actually adding the filament. So again, that is the deciding factor overall. And again, this is going to bump up my 0.1 to 0.125 layer thickness. And once it's into geometry, you will see where these are going to fall at the bottom and the top. All right, so let me switch back over. And let's go ahead while that's doing its thing. I'm going to go ahead and say, you know what, once we're happy with this, we want to print it again. So I'm going to go over to print. All right, so it will tell me if my printer is online and available. So if I come over and say, look, I want to go ahead and send this to the, Markx machine, and tell it, it tells me here again, here's the time and the actual volume. And then I just go out and actually either export it. So I can actually export the build, and that will actually create a file for me to put on a flash drive and take over and stick into the printer and print. If it's available, I can actually just pick it online and just hit print. But let's go ahead and hit print. All right, so let's just add to queue instead of hitting print. I don't want to print it now, so it's going to go through. While it's doing that, let's go take a look at this. This is almost done. All right, so that's done. All right, so let's go take a look at the internal view again on this. Now that it has fiber in it. All right, so now let's zoom this up a little bit. All right, so now you see some blue here at the very bottom of the part. All right, so that little part of that is actually a couple pass of concentric carbon fiber with an isotropic property or isotropic path of the actual carbon fiber. So if you don't necessarily want those down there, this is a fairly thick part. So let's say I actually want this carbon fiber to be more towards the top. Really wouldn't need it in this, but let's say we do want to move it, so we can always just move this. So you can kind of just drag that to approximate where you kind of think you'd want it. And then you can just kind of drag this to get how many layers you want. So, looking at 3 or 4 layers of this material. So it'll actually re-slice it on the fly here. Yeah, let's see if this is probably still trying to do its thing here. Let's go ahead and cancel that. I'll show you the print on the next one. Don't want to use all my computer resources. Even though it's cloud slicing, I still have to have all these pages of Chrome open, and Chrome uses a lot of memory. All right, well, It's, there it goes. All right, thinking really hard. So basically now I move the carbon fiber from the very base more towards the middle. So a little more higher than I needed it. But if I wanted it dead center, you would know how many layers this is, because you can always go into a 2D view. And when you go into 2D view, you can kind of slice through your geometry and kind of see, well, so as I go through, there's, what it does is actually prints the mesh. And when it gets close to where the carbon fibers are going to go, it prints a solid base, a couple layers, then it starts printing the carbon fiber. So again, this is isotropic, so it prints 90, 0, 180, 270, and then it switches back to a solid base. Then it goes back into the mesh, and it goes through, so you can actually see kind of where it starts to transition in the top face. So right there is where it transitions into the top. So if I want to know exactly where the dead middle is, I can kind of, now I know where the layer is. I can come over to my carbon fiber and just kind of drag that down to where I want it. All right, so don't really need to do that. Let me just show you how to create my own layer of carbon fiber. So if I maybe know if I need a layer of carbon fiber to maybe support these ribs or something, I can come over and just kind of drag, again, just kind of drag an area right here. And as I drag through, you see it highlights the parts. So let's say, you know what, right in this area right here. So that looks like a good area to try to put a path. So I'll come over here now and say use fiber. All right, again, what we use isotropic fiber by default, but if you just want to use concentric, so it just makes ring paths, it will, but let's just stick with the isotropic option. How many concentric rings? Let's maybe bump that up to maybe 4. And let's go ahead and say create group. So it'll do this little slicing on this area. And if my path width is thick enough, it will go through and actually add that in there. So it's doing it right now. So there we go. Rotate it around so you can see a little better. All right, so it actually created all my concentric rings. I think I said 4, then it went in and created my isotropic path. All right, so let's go ahead and turn on all sections. My support material looks like I'm run out of memory. There we go. So it refreshed. So there's the entire part. There's where the carbon fiber is. So if you wanted it in multiple areas, you just go through and take time to place the carbon fiber is. So now you can see where we're looking at on the part, cost, material, how much onyx, how much carbon fiber material is going to be used. Then when you're done, you just go ahead and save it. And this is be ready for printing now. All right, so I can go over to my prints. And again, go ahead and tell it what you want to do. If I wanted to add a part. So if I had maybe a secondary part, maybe the cap that kind of went with this, I could always come over here and go, so you know what, I actually want to add that to it. Done. It's underneath it, so let me move that out of the way. So I have an error here. So if you try to push your part outside a certain area, what it's telling me is if I'm running carbon fiber in this, what happens is it actually prints a little bitty carbon fiber tower back here. So if my print or my model is too close to the back edge, certain overhangs cannot get carbon fiber. So obviously just the remedy is just to kind of move it off that back edge. So there we go. So now these both parts will have the carbon fiber printed in their respective locations for this part right here. And we're looking at now a cumulative 2 days, 17 hours total for both of these parts. So I would, again, now just say, you know, pick my mark X and print, which I'm not going to do because that's probably not set up to run sitting in the St. Louis office. I'd have to tell somebody to go make sure that everything is ready to go. It will warn me, but more likely I won't have remote access to do the things I need to do to make the print. So I would, you know, print to my local computer or my printer is much easier than trying to print to a remote printer, but all the same, it works the exact same way. All right, so that takes us back to the library page. Again, these can't think of really anything else to tell you. So again, appreciate taking a look at Eiger. and what it can do and how it's actually set up, let us know. Please contact us over at Swoosh Technologies if you have any further questions on the Markforged printers. And again, we do have the information on the printers themselves, and we also have the ability to sell you materials through our web link. So please, again, feel free to contact us at Swoosh Tech. Appreciate it. Thank you, folks. Bye-bye.